Hi everyone and welcome to the channel. Have you ever seen a giant power transformer, a big electric motor or a generator and wondered how does that actually work? At first look, they seem really complicated. But don't worry, in this video I will explain everything in a simple way so anyone can understand. Now, here's a fun trick to remember the basics. Just three letters MIT. No, not the famous college. In our case, MIT stands for Magnetic Field, Induction Principle, and Torque Principle. Or you can remember it as my intelligent transformer. A simple way to recall the core principles behind transformers, motors, and generators. We will use this to understand how these electrical machines really work without going into too much technical depth. Let's start with M. M stands for magnetic field. The most basic concept is that an electric current produces a magnetic field. This is the absolute foundation for how all these devices operate. Now, this magnetic field can be created in two ways. First one is using direct current DC. DC creates a constant and unchanging magnetic field. The second one is using alternating current AC. Since AC keeps changing directions, it produces a time varying or rotating magnetic field. We see this in a DC motor, where supplying DC to the stator produces a steady magnetic field, and in a transformer, where AC in the primary coil creates a time varying or changing magnetic field, and also in an induction motor, where the AC supplied to the stator windings generates a time varying or rotating magnetic field. Next come to the letter I. I stands for induction principle. This is governed by two famous laws, Faraday's law and Lenz's law. Faraday's law states that whenever a magnetic field cuts a conductor or a conductor cuts through a magnetic field, an electromotive force or EMF is induced in that conductor. In simple terms, magnetism can create electricity. Now coming to Lenz's law. Lenz's law adds a crucial detail. The induced current will always flow in a direction that opposes the magnetic change that produced it. So, where do we see this in action? In the case of transformer, the time varying magnetic field produced on the primary coil cuts the secondary coil so that an EMF is induced in the secondary coils. And in an induction motor, the rotating magnetic field from the stator cuts the rotor bars so that an EMF is induced in the rotor. As a result, current starts to flow in the rotor circuit. Like that, in an AC generator or alternator, a constant magnetic field on the rotor is rotated by a turbine, cuts the stator coils so that an EMF is induced in the stator coils. In before three cases, magnetic field rotates and cuts the conductor. But in case of DC generator, for example in Megger, the scenario is different. The rotor coils rotates and cut the constant magnetic field of the stator so that an EMF is induced in the rotor coils. Now coming to the letter T. T stands for torque or rotational force. This is the principle that actually creates movement. Here's the rule. When a current carrying loop is placed in a magnetic field, a rotational force or torque is exerted on the loop due to the interaction between the magnetic field and the current. This is a magical movement, where electrical energy converts into useful mechanical energy. This is the core principle of a motor. This is essential for a motor's operation. In a DC motor, we put a current carrying loop into a constant magnetic field and the resulting torque makes it spin. Similarly, in an induction motor, the current induced in the rotor interacts with the magnetic field, creating the torque that gets it moving. So let's put it all together with our MIT framework. A transformer uses the magnetic field and induction principles. A generator also uses the magnetic field and induction principles. But the motor is special. It uses all three: the magnetic field, induction, and torque. So the next time you see any of these machines, just remember MIT: magnetic field, induction, and torque. You will have a solid basic understanding of what's happening on the inside. If this helped you understand these electrical giants, hit that like button. Subscribe for more engineering tutorials. Thanks for watching.